Hi everybody, so this is where we talk about the chi-square test. This is chapter 8, and this gets a little complicated as far as material goes, but we'll break it down and try to make it a little easier for you. So what is it? It's basically just a test that measures the statistical difference between a study group or samples. That's it, that's all we're trying to do. The chi-square works when you have a dependent, so the outcome variable, that's nominal or ordinal. And just to remind you, a nominal data is not greater or less, it's just named. So that's things like gender, race, color of ball used in the experiment, whatever. Ordinal is ranked in some way. So we can use nominal or ordinal data in this one. Now make sure you know the null, which is of course that nothing is actually different, and then the alternative hypothesis, which is really your hypothesis of what you think is going to be the change or the difference. So you're going to make a 2x2 table to display your data. So I have a very simple one here. So you can see here we have males, females, and whether or not they were transfused or not transfused, and the total. And the totals are as easy as that, right? So 30 plus 20 equals 50, 40 plus 20 equals 60. If you add it all together, we get to 100. So that's obviously a very simple table. Most of these experiments get much more complex than that, but we're going to deal with some easy examples. Next up, we have to figure out the degree of freedom, which is very similar to Kevin Bacon's 6 degrees of freedom, but it's a little bit more complicated on the math. So it's the number of values that are free to be unknown. So it's equal to the number of rows, minus 1 times the number of columns minus 1. So at the end of the day, it's, and a 2-time table like we just created, it's 2 minus 1 times 2 minus 1. So 1 times 1 equals 1, which means a table that small is only going to have 1 degree of freedom, which means later on down the road that's going to help us figure out some numbers. So then we're going to calculate the test. So once you have your table set up, you can do the math. But guess what? Excel has options that you can actually perform this function without having to do any math at all. I'm going to walk through the very simple processes. Again, the goal here is not to get you to figure out how to make this math work for you. It's understanding how the test works and when it works for you and when it won't. So the first step is to calculate the expected frequency for every single cell. So obviously if you have 1,000 cells, you need a computer program to do the math. For a very simple equation of our 2x2 squares, that's not that complicated. So the expected frequency is the row total times the column total divided by the grand total. Okay. Then you follow the equation to the right, which is this one here, for each cell. Okay. So all this sign right here means is it's the sum of everything. So after you've added all of this up, then you have your total number. Then we have to find the degrees of freedom, which is again this here, and look up the results in a chi-square table. Again, we're not going to do the math. Nobody's asking you to do math because, you know, this is a lot to kind of keep up with, even in a small table like the one that we have. The goal here is that it's going to give you a number, and you need to understand that you should look up that number in a chi-square table. So to figure out the significance, we have here a chi-square distribution with degrees of freedom. So if you know what your degree of freedom is, you know what number you need to hit in order to get a significant number. So if you recall, the alpha is the number that you chose that's going to end up being significant. So for many scientific studies, 0.05 is a good alpha. For some scientific studies, especially drugs and things that may cause harm, 0.01 is a good one. And if you want to be almost entirely positive that your results are correct, then you can push it all the way out to this 0.001. Okay, so that's the alpha. So if you picked an alpha of 0.05 like a standard study would be, you need to have a number greater than or equal to this one right here. Okay. So if you have a number greater than this, so let's say you have a number of 4.0, it's greater than this number, and therefore your probability of exceeding the critical value is 0.05. That means you've proved an association, which is the whole goal of the chi test, right? It's to prove the association between something, or whether there is something there or not. So if your number is less than that, you failed to prove a difference. And when you fail to prove a difference, that means you have you're agreeing with the null. You have failed to reject the null. And again, that null is kind of the opposite. It's saying there's no difference there when your hypothesis is that there is a difference there. So that's all this is looking at one of these tables here and figuring out whether or not your numbers meet those significant markers. So the chi-squared test, though, doesn't tell you the direction of the difference. It doesn't tell you if one thing's better or worse than another. The only thing it tells you is that something is or is not statistically different. And then it has to be significantly different for that number to make, matter to you. So it may be enough that maybe all you're looking for is to decide, yes, there is a difference here, no, there's not, but typically it's only the beginning of your statistical analysis. So when can you not use a chi-squared test? So all of your cells have to have a value greater or equal to 5, and if you have less than 10, you still have to run something called a Yates continuity correction, which most computer programs will do for you on their own. The last thing we have to wonder about or make sure that we are adapting for is that the sample isn't random or independent. So if your samples are paired in some way, say, for example, the example the book gave you was a husband and wife team. So in order to be selected, the husband had to have a certain type of problem, and therefore the wife was automatically selected. So that's not a random sample, and those results are not independent of each other. So in that situation, this particular test isn't going to work. That's all I have to say about the chi-squared test. If you have any questions, let me know.